This is Precalculus Chapter 13, Lesson 5, starting on page 889. Okay, so this is we're back at statistics, all right? And this whole lesson deals with the symmetrical distribution, okay? So a symmetrical distribution in your higher level statistics is really called a normal distribution. In fact, that's how they calculate ACT scores. If you looked, and probably SAT, if you looked at the scoring on the ACT, it always changes by a couple of questions, right? You could make a 36 and not get every question correct. It's because of this normal distribution concept. With a normal distribution looks just like this. It's called a bell-shaped curve. All right, normal distribution is always a bell-shaped curve. And with a normal distribution, the mean, the median, and the mode are all the same value. They're all the same value. So it's symmetric about that maximum point of the bell-shaped curve. All right, so we just learned the standard deviation. So there is something, I want us to turn to page 892. Page 892. So with every normal distribution, I need to make my curve a little wider so I can break it out a little better. Not come down so. We use the standard deviation to determine where the population lies within this curve. So if we're talking about the ACT, the mean median mode hovers around 20. I think it's actually like 21 most recently. So let's just say the ACT score, mean median mode, was 20. If this represents that maximum point, and it is normally distributed, then 50% of the people scored lower, half of the population lies to the left of the mean, and half of the population lies to the right of the mean. All right? And so we can further divide that down by using the standard deviation. Remember, the standard deviation says how far on average is each output, that data, away from the mean, right? Because when we calculate the standard deviation, the first thing we do is we calculate the mean, right? And we take each number, how far it is from the mean, we square it to eliminate the negatives. Because really, if we, in the previous example that we worked, remember the mean was 10, right? And we had 6, 8, 10, 12, and 14. This was the mean of that example we worked a minute ago. Do you remember that? If we didn't square the numbers and just asked ourselves, how far is each one away from the mean, we would get -4 plus -2 plus 0 plus 2 plus 4. What does that equal? 0. That's why we square it. divide by how many there are. So we're taking the average of the distance, right, squared, and then we take the square root, so that we're not just saying 0 divided by 5, right? That's what gives us the standard deviation. It's how far it deviates from the mean, okay? And so we can look at the population. And I don't know the standard deviation for the ACT, but I do know that standard deviation is used by many professors to calculate what is going to be a C, right? What is going to be a B? What's going to be a D? Where does the A lie? Where does the F's lie? Particularly in your fields of math and science, the ones that I'm more closely aware of. All right, so look at this. So let's say, I'm just going to make up numbers. So let's say the ACT, the mean is 20, like I said. And let's say the standard deviation is standard deviation is 4. Okay, I'm just making this up. All right, the standard deviation is 4. That says that's the average distance everyone is. All those scores are away from the mean. Then I can use this to find out what percent lies in what range of scores. All right, so one standard deviation from the mean to the left would bring me to what score? What would my score be if I was one standard deviation to the left? 16. It would be 16, that's right. 20 minus 4 is 16. One standard deviation to the right would bring me to what score? 24. And statistically speaking, 68% of the population would lie within one standard deviation to the left and right of the mean, of that average, when you have a normal distribution. All right, now let's go another standard deviation. I gotta make my lines not so big. Let's go another standard deviation. I should use another color, huh? One more standard deviation to the left would put me at what score? At 12. And one more to the right would put me at 28. Such that, look at your picture. This would include, I'll go up, 95% of the people. That probably is pretty close. Probably 95% of the population score between a 12 and a 28 on the ACT. I mean, that's probably pretty close, huh? So 68% are always within, in a normal distribution, 68% are always within one standard deviation of the mean. 95% is within 2 standard deviations. And then one more standard deviation. Where would that put me at the bottom? That'd put me at 8. I should use a different color. 8. Huh?
Can you even get an 8?
I think you probably can.
I think if you just put your name, you can.
I don't know. Okay, that would be 8. And above would be a 32, right? And that is really the majority of the population. That's 99.7% of the population score between an 8 and a 32. Well, there's still some area out here, isn't there? Did you notice it? This area and this area represents 0.3% of the population. Those areas combined, 0.3%. Because everything has to add up to be 100%, right? Okay, so I want to take this and let's decide if we can figure out what percent of the population, so we're going to ask some questions. What percent of the population would score below an 8? Just here, below an 8. What is true? Yeah? 0.15. How did she get 0.15?
She took 0.3 divided by 2.
That's correct. 0.3% and divided it by 2. Okay? What percent scores above a 24?
Would you take 68? Would you add together 95 and 99.7 and subtract 68 from that?
Okay.
Mm.
Let's think about this. I don't know what color to use. Green. Okay. What is from here up? What percent is that? 50%.
Oh, so you would take 68 divided by 2?
Yes, then take 68 divided by 2. What is that? 34. So this piece here represents 34%.
And then you would take 50% minus 34%.
50 minus 34%.
Which is 26.
16%.
Oh.
Yeah, you didn't borrow the,
Yeah.
But you were right, yes.
I was
You were
close.
thinking right, yes. 16%. So you can use this normal distribution and really calculate anything, right? What about below a 12? I mean, we could do all kinds of things. Less than, what percent scores less than a 12?
Well, to this side of it, it's 50.
To this side is 50%.
Then you would subtract 34 from those. No. Yes. No.
What would you subtract from it? What would you subtract from the 50%?
95 divided by
Half of that 95, right here. Half of 95, which is what?
47.5.
47.5. So what is that? 2.5%? Is that right? Okay, and you can ask, what percent score between a 12 and a 24? See how you could use this to calculate any of the pieces of the normal distribution. Okay, so what do teachers do? And I can only account for some professors that I am aware of. They calculate the mean of the score because the means are so very low, like in physics 1. And they say, okay, the mean, that's a C. We're going to go ahead and give that mean a C. And then they go out each way. That's a B, that's a D, that's an, or the other way around probably. This way, you know, A, B, right? So they look at standard, like literally one of my son's professors said, that's what he does. Looks at the mean, then he goes out standard deviations, and that's how he broke down the grade. All right.